Hello everyone, this is Mr. Guy here. I'm going to teach you guys about finding the volume of a cone today. Hopefully you already watched the video from yesterday about the volume of a cylinder because the volume of a cone is actually going to relate very directly to that. Before we go ahead and talk about what the formula is for the volume of a cone, what I want you guys to do is go ahead and watch a video. You can see in my note sheet I have here, it says a QR code and a link. You don't need to do any of that. The link to this video is actually going to be in your Schoology, that classroom that you're using. So if you can please go ahead and just click on that video. So in a moment here, I want you to pause this video, go click on that video and watch it, and try to see if you can figure out what the relationship between a cylinder and a cone is. So for example, while you're watching, you might see that you think that the cone is 5 times as large, or the cylinder is 4 times as large, or whatever you see, that's kind of the relationship we're looking for. Okay, so right now, go ahead and pause this video, take a look at that one, and see if you can see what the relationship between these volumes is. Okay, hopefully you went ahead and paused the video and went and watched the water pouring going on over there. And hopefully you noticed that 3 of the cones were actually able to fill up the cylinder. So the relationship between the 3 is that the cone is 3 times as small as the cylinder, or 1/3 the size. And that's actually going to lead us to the formula for the volume of a cone. Let me click on my pen tool here. The formula for the volume of a cone is actually going to be the volume of a cylinder, which, if you remember from yesterday or the last video that you watched, would have been pi r squared times the height. And what we're going to be doing is we're going to be taking that formula and kind of changing it a little bit for the cone based off that relationship we saw. The cone was 1/3 of the size, or the cylinder was 3 times as large. Because in math, we don't just pull these formulas out of thin air and say, oh, look, I just figured this out. This is how it works for a cone. We try to look for these relationships, and that's where these equations come from. So we're going to be taking this pi r squared times h, and we're going to be dividing it by 3. Where is that coming from? It is because we are taking the formula for the volume of the cylinder, and we know that the cone is 1/3 the size. So if we take that formula and divide it by 3, we'll get the volume for the cone that we're looking for. So basically, this is going to boil down to being very, very similar to how you found cylinders yesterday and the day before. You're going to have to figure out what your radius and what your height are, and then plug them into this formula, and you'll get the answer. Okay? Let's go and take a look at some example problems. So for number 1 here, again, I need to find the volume of a cone, and I'm going to use 3.14 as my pi. We'll change that in a moment and deal with pi if I don't have to use 3.14. So how's that going to look? Well, first I need to identify my radius, and I actually went ahead and already circled this for you. The 14 is my radius. The radius is always part of that circle component part of your cone. So I'm going to write out my formula. So my formula is going to be pi r squared times the height divided by 3. And now I'm basically going to fill in each spot that I need. So pi we're going to fill in with 3.14. That's our approximation that we're going to be using. R I'm going to fill in 14 for, because 14 was my radius. And then for the height, I'm going to fill in 23. All right, so that's what I'm going to fill in my spots, and the whole thing's going to be divided by 3 to give me the volume of a cone. I'll then go ahead and type this into my calculator, and putting in my calculator will go ahead and tell me what the answer is. Now, if you're using your calculator at home, you need to be a little bit careful about this. We're going to make sure we put this whole numerator here into parentheses. So when I go ahead to type this in my calculator, I don't know if you can see this super well, but I'm going to try to show you a little bit here. I'm going to go ahead and plug in this top part by putting 3.14 times 14 squared times 23 and putting it all in parentheses. You see how I put that in parentheses and then close the parentheses? Everybody see that? And I'm going to go ahead and I'm going to divide by 3 at the end, and then I'll go ahead and hit enter, and that will give me the answer that I'm looking for. Now, I need to be careful because I want to make sure I give them what they're asking me for, and in this case, they're asking for the nearest cubic unit. So my answer is going to be 4718, because I'm going to round it to the nearest cubic unit. In this case, it's 0.3, and I don't need to include that for the rounding for me 4718. Also, I want to make sure I give them units. We're finding volume. Our units was millimeters, so my units are going to be millimeters cubed. The cubed comes because I'm multiplying 3 different units together to get this. Volume is always in cubic units, so that's going to be my answer. It should be very similar to the cone. So basically, you just do the same thing and divide it by 3. Okay, so find that radius, find the height, plug them in, There's your answer. What I'd like you guys to try is go ahead and try number 2 on your own. So in a moment, I want you to pause the video, go ahead and try and calculate number 2, and then unpause and you can see my work and we can check our answers together. So right now, go ahead and pause the video, find the volume of that cone, and then we'll meet back together and talk about it. All right, so a little time travel into the future. I actually went ahead and solved this one. Hopefully you did as well, so you can check your answer with me. I ended up getting an answer of around 5 feet cubed. Again, we're rounding to the nearest cubic unit, so that'd be the nearest cubic unit, 5 feet cubed. Now you'll notice one other thing I did as well in terms of putting this in is I put this little squiggly equal sign. I actually added in over here as well. That's to show somebody who was looking at this that we're rounding a little bit to know that's not the exact answer. We rounded it to something, in this case, the nearest cubic unit. So it's around 5 feet cubed is the volume of this cone. So that's kind of our basic way to solve it if we're using an approximation, but sometimes people want the exact answer. And when we're dealing with pi, that gets a little tricky because pi, as we all know, is an irrational number, meaning that it would take the rest of my life to write everything out and I still wouldn't get to the end. It goes on forever, has no repeats, nothing continues, right? So you would just sit there for the rest of your life. What a pointless existence that would be to keep writing numbers out and still never reach the end. So what we're going to do is we're going to actually show things in terms of pi. Now, this can get a little confusing for people because they're like, whoa, I want an answer. You're not going to give me a number answer. But it actually makes the math a little bit easier because we just kind of ignore pi and just kind of leave it there and just treat it like a variable. So let's kind of look at what that looks like. Now, down here, you'll see that we have a couple examples that combine some cones together and combine some of these, the cylinder as well. But that's not going to add too much onto our problem here. So let's take a look. So over here I have 2 cones. We can kind of go ahead and find the volume of each of these cones separately and then sort of add them together to figure out what the total volume is going to be. So when I go ahead and take a look at this for number 3 here, I have my cone over here, which is a 10-inch height and a 5-inch radius. I have my cone over here, which is a 13-inch height and a 5-inch radius. So I'm going to go ahead, I'm going to find the volume of each of those. So I'm going to go ahead and write, all right, so for my volume here, for this cone right here, I'm just going to write pi instead of 3.14 this time. Again, we're going to write this in terms of pi, times my radius, which is 5 squared, times the height, which is 10, over 3. And yes, that is a 2 up here. Sometimes the writing's not that great. People have me for class notes. Not that much worse than my writing on the whiteboard. Over here, if we go ahead and find this one, it's going to be pi, and then we're going to multiply this by 5 squared as well. And then the only difference is we're going to multiply this one by 13, and then we'll go ahead and put this one over 3 as well. And then what we're going to do with these two is we're actually going to add them together because them combined is what's actually going to give us the entire volume that we're looking at here, okay? So now I'll go ahead and I'll just do each one separately. So over here, I'm going to have 5 squared times 10. If I go ahead and take my calculator, I can put that in, and I'm actually going to get that this is 250 when I multiply these together. So I'm just going to write this as 250 pi over 3. Now, on the other side, I'll go ahead and do the same thing. So I'm going to have 5 squared times 13, which I don't actually know off the top of my head. So I'm going to go ahead and do that real quick. And I'm going to get 325. So over here, I'm going to have 325 pi over 3. Now, what's kind of nice about adding these two fractions together is that they both have the same denominator. So when I go ahead and add them, I can kind of just carry the denominator over. I don't have to do any common denominator tricks or anything. So I'm really going to get 250 pi plus 325 pi over 3. Now, what's nice, remember I said before about, hey, I want the exact answer. I want you to write it in terms of pi. We kind of just have pi floating around here instead of putting 3.14 in for it. We just have it sitting there. Well, how do I deal with it? I kind of just treat it like a variable, almost like I would x. So what I'm actually going to do is I'm going to go ahead and just add these two numbers together as if they were coefficients. So my answer is actually going to be 575 pi over 3. Now, before we go ahead and say this is our final answer, we want to make sure that this doesn't simplify any further, because if it does, we need to make sure we give the simplest form. In this case, 3, the only number that goes into it is 3. So I just need to check and make sure and see if 3 goes into 575. So I'll take my calculator here. So, all right, 575 divided by 3. It does not look like it goes in at all. In fact, if you look at this, I get 191 and 2/3, okay, and 0.6 repeating. So this actually is my final answer right here, 575 pi over 3. Now, you might be saying, Mr. Guy, that's a really gross answer. What the heck does it even mean? If your parents are in the room, they walk in and say, how is that an answer? I don't understand what that means. That answer is actually exact. That is the exact answer of what it is. If we were to go ahead and put something in for pi or put it in our calculator and get an answer, we're going to get a decimal approximation because, again, pi goes on forever. It's impossible to calculate something with it, okay? What I'd like you guys to do is go ahead and try number 4. Now, be careful with number 4. It's very similar to number 3 in that we have two shapes together. However, notice that this bottom shape here is a cylinder. So when you go to calculate it, make sure you don't divide that portion by 3 because it's a cylinder. It's actually just going to be the normal calculation that we have. So I'm going to go ahead and do the same thing we did before. I'll pause the video, go ahead and take your time figuring out the volume of that cone and that cylinder and add them together. And then we'll meet back and talk about it and make sure that we all have the same answer. All right, we're back. Another time jump into the future here. So if you go ahead and take a look at my work here, if you notice what I have here over here is where I wrote the volume of the cone, and over here is where I wrote the formula for the volume of the cylinder. If you notice the cylinder, I did not divide by 3 because it's a cylinder, and we know that formula from yesterday. So I go ahead and I plug this in. I simplified a little bit. I got 360 pi over 3, which is 120 pi. That's my final simplification of the volume of that cylinder, of that cone. Over here for the volume of the cylinder, I multiplied, got 306 pi, and then I added those together, and again, treating it almost like this is a variable, and got 426 pi would be the volume of this shape. Thank you guys for watching this video. Hopefully you now know the volume of a cone, at least the formula and how to use it. And now you're going to go ahead and try a couple different problems on your own and show us that you know how to use this formula. Thank you very much for watching.